Hello everybody and welcome to Handmade Hero, the show where we code a complete game live on stream. We added yesterday the ability to do sort of per element sorting, and we did that in kind of an interesting way, I thought. Which, that's something different. We had sort of had this plan to do something a little more complicated, and then right in the middle of implementing, I realized there was a much simpler way to do it. And so we ended up doing it in a much simpler way, and it seems to work quite well. And at the end of yesterday's stream, we actually used the cycle detection that we put in there to determine that we didn't actually have a bug in the comparison as well. So the cycle detection ended up being kind of useful too. So it was a pretty good day all around, I think. And I'm relatively happy with it. However, at this point, it does mean that I think we've moved into the firmly into the territory of now we've got to go back and finish up our Z layering stuff. Because we've got sorting working inside a layer properly. We don't currently have our layering stuff working. And so what that means is, of course, if we go into the game at the moment, because we sort of left it in a sort of, as I often say, zygotish state. So if we kind of go in here and we run it, you can see that we've got sort of this one thing, this one room, if you will, that's doing what we expect it to do now, and that's good. But we've got this stairwell here that we had made, and it's already still using the old sort of perspective transform that we said we didn't want for things inside a room. Like, we just want these should just be up higher in Y, but they shouldn't be going to the side or getting larger like they are. So that obviously something we need to fix. And then similarly, if we go and actually start allowing more than one room to be added instead of, oops, that's not where I want to be at all. So if we allow two rooms to be added stacked on top of each other, we can quickly see that also our sorting won't work properly, because our sorting is designed to only sort inside a single room, given the rules of a single room. And that's just because it's a 2.5D sort, so it has to make some concessions, but you can see right now that this is totally wrong, right? And the reason for that is our sorting rule doesn't really handle the idea of layers of Z slices on top of each other. And, you know, we could try to make that work or whatever, but the goal is not to make the sort handle everything. That was never the goal. The idea is we actually want to just slice the world into these slices and then have them sort separately, which we know works. That was always the plan, and so now we need to make that happen. And as you can see right now, you know, it's totally unworkable as it is, because these things are just randomly sorting and you can't make any sense of it whatsoever. So what we need to do is we need to take a step back and we need to go finish that slicing so that we can see whether our sort rule actually does work if we give the renderer slices to work with. Now, this is going to be a pretty difficult excursion for us. It's going to be a little difficult for me in the sense that this is the kind of work that normally I do over probably the course of 1 or 2 days in a really concentrated, like 4-hour pair block or something like this, where I really get in there and get everything right. It's going to be really hard as a thing to do on the stream, because breaking things up into hour chunks and talking while you're doing it is kind of difficult. So it is going to be a little difficult for me because it's an architectural, like, reorg kind of thing, which can be difficult. But it's also going to be kind of difficult for everyone else to follow too, because I'm probably going to be, you know, I'm moving things around and sort of talking about like the feel of things and how they go. So I apologize for that, but that's just something that you have to do periodically. Like I've always said, I'm really into exploratory architecture, which means you kind of have to feel your way out to, like, okay, now I see how this works. That's the only way that really good architecture ever happens. And certainly the architecture that is going to be best for Handmade Hero, which I think we're slowly annealing into, is not one that we ever could have conceptualized at the start of the project. So if we had, you know, tried to write out some UML class diagram of how this game was going to work, we would have been so far away from the actual correct architecture, it would have been hilarious. And so, like, just to sort of give some encouragement, when you find this sort of thing happening, you want to embrace it, don't discourage it, right? You want to embrace the idea that the architecture gets better over time and that you're exploring towards a good architecture. And if you believe that what good architecture is thinking about everything up front and getting this design and then plowing, you know, forwards on it after you finalize it, like this is the design, That's where bad software architecture comes from. So, always embrace the sort of forward flow of the architecture. And a lot of what you do when you're programming is absolutely about trying to make sure that you have a code base that's fluid enough that you can make those decisions and move forwards and get to better places, rather than something that's really been rigidly codified and has no flexibility to get to where it needs to go to be well working and fluid and fast and efficient and all that. So that's what we need to start working on now, and so that is what I'm going to start looking at. Now, if you recall, we actually sort of started looking at this, and that's what made us decide we needed to do the sort, and so we went and did the sort. But if you recall, before we finished doing the sort, we had actually sort of started this conceptualization of layering, and you can see here where we've got this relative layer convert to relative layer, and it does the temp Z thing, right? And you can see what ended up happening here is I just patched it really quickly. So what was supposed to happen, or what was happening in here, is when we call convert to layer relative, what would happen is it would return a relative layer value, which is basically saying like, oh, here is which slice of the world this particular sprite is on, or whatever. But then the other thing for the value passed in, it would modify the value passed in to make it be now just an offset based on that layer. And so what I did to sort of patch it out so that we could have two rooms still on top of each other just while we were testing other stuff, is I pass a temp value there that never then gets used. So if we want to return to the previous way, the previous state of the program before we put the sort in and when we were just working on the layers, it would look like this. And at that point, what happens is everything's flattened down into one plane. So now you can see we actually have two rooms here, okay? But instead of drawing those two rooms on top of each other, we've actually truncated them out so they're actually drawn in the same place. And you can see that flip happen here. So no matter whether I go up or down either way, like here I go up, doot, doot, doot. And you can see the flicker happen too, where it's like the two tiles are being rendered on top of each other and they're fighting for who gets drawn first and all that, right? So this is basically just drawing two rooms on top of each other. But that's actually what we want, right? We want to flatten all of the rooms down into the same space, essentially, and then we just want the renderer to know that each one is rendered at a different offset in terms of perspective. Now, just to refresh your memory, since it's been a while, let me just reiterate why we are doing that here on day 313. Oh, I forgot to say, today is 313, so if you want to follow along, day 312 source code is the right code to start with. What's going on? My Milton seems to think I'm a mouse again. That's weird. I'm going to reopen Milton. Hello. There we go, much nicer. Yeah, I don't know why that happens, but sometimes Milton decides that it's in mouse mode. There we go. Okay, so let's talk about the slice again really quickly, just so everyone's on the same page. So here's what we've got. We have two sort of areas in the world, right? And we've got these sort of trees around here or whatever, and maybe this one's got trees around it too, and who knows? These are going to be whatever they are with the actual game art, but point being, you've got two things stacked on top of each other. So what we want to have happen is we want to have two separate conceptualizations of what it means to be up in the world, right? Up goes this way, it's our Z value, but we have two different things that's going to mean. So when you're looking at an individual slice of the world, what we want up to mean is just displacement in Y. So for example, if we have a stairwell should actually just look like this kind of. Right? It should be basically the same size all the way up, okay? And it should be right in line with each other. And right now, as you see, we have kind of a perspective stairwell, so it kind of goes off at this direction, and the tiles get bigger as they go. So when we're looking at a single slice of the room, we want to see all of those Z values are just converted to Y displacements. And that's it. No scaling, no x displacement, just y displacement. So it's true orthographic, one sort of tilt orthographic. So what we're essentially saying is if you are looking at a particular slice, then something that is hovering above that slice, or that is up, from that slice, like so, that thing, that z, the reason that I was saying we need to always think about z relative to the layer is because that portion of the z needs to get converted to a y displacement. That's what we want for the art style. Okay. Now, on the other hand, this displacement here, so the fact that this floor is up above this other floor, this is a separate slice. And what that means is that everything on that slice, who by the way have their own relative z displacements, everything on that slice needs to actually be scaled so that it's in perspective, in the sense that it does get bigger. And it does displace in x and y, right? So fundamentally what we're trying to do here is basically render the world in slices and take those slices, which have z offsets translated as y offsets, take those slices and scale and modulate and do whatever effects we want to the slices as wholes. And by the way, while we're at this, we would like to correct the alpha blending of these things so that they alpha blend away or fog in or out or all those sorts of things. We want that to be consistent as a layer. Because you remember we sort of had this bug it's not very noticeable bug, but I find it looks very unprofessional if you leave this kind of thing. And I see a lot of games that have this actually. If I've got a tree, and right in front of it is another tree, there's a region of overlap that's, say, right here. So this sprite gets drawn and this sprite gets drawn. Usually what happens is, A gets drawn before B, and so that's why the part of A that's not visible is not visible, right? That's the way we're currently doing it, is we're drawing back to front. Now, when we draw back to front, if the alpha level that we're using to draw everything at, so if the opacity of these two things happens to be 100%, everything's fine, right? You just see two trees, and they appear to be B in front of A, just like what we wanted. However, if we then set the opacity to 50%, because say, for example, we're fading out an alpha layer that's getting close to the camera, like, when you go down a stairwell or something and it's supposed to kind of come up at you and disappear. When we reduce that to 50%, well, this one will become 50% translucent, which is fine. But then this tree that gets stuck on top of it, well, this part of it will be 50% translucent, but this part already had a 50% layer on it, and now it's having another 50% layer put on top of that, right? And so if you think about what that ends up happening to the total translucency of this area, it is not at 50% anymore, right? Because you can imagine what's happening. There's something underneath this, the stuff that's below this layer, right? We'll call that A. Well, let's not call it A because I already did that. Let's call that, what am I call that? Let's see here. Let's call this, I'm going to say M and N. Okay. Well, no. I'm going to do that. M is what's behind. And then on this layer, we've got, I'm going to talk about the individual objects. We've got the two trees, and the two trees can be A and B, like we had there. So here's A, here's B, and N. Okay. So if you think about what happens here, right? If the bottom part is M, then that's what we're starting with, right? And what we end up with, if we imagine that this layer was labeled N or whatever, what I want to see if my opacity level is 50%, right, is I want my final pixel to be 0.5M plus 0.5N, right? That's what I want to see. I want to see 50% of the underlying and 50% of the thing on top, okay? Now the question is, will I get that with this process? Well, if I am to draw M first, right, well, we know that's just what's in the buffer, right? So we start with M. Everything's cool. If I was then to draw just some single object called N, right, then using my linear blend, I know I would have, 1 minus whatever the alpha value is, N, plus the alpha value of M, right? And that would be my pixel. So if I set my alpha value to 0.5, what happens? I get 0.5 here and 0.5 here, right? Because 1 minus 0.5 is 0.5, and the value itself, 0.5, is 0.5. So I would get exactly what I wanted if I just did one rasterizing operation. But we don't have one rasterizing operation in this case. We have multiple. We're drawing multiple sprites. So if all we do is set those individual sprites alpha value, then what we get is a repeated application of this formula, right? So the first time through, right, if I repeat this formula, 1 minus alpha a, remember that's our back tree, plus alpha value m, well, I'm a pretty happy camper because then I get 0.5a plus 0.5m, right? But now I come to draw b. Well, this is now what's in the buffer, so I end up with 1 minus alpha times b plus alpha times this whole thing, right? 0.5a plus 0.5m. Well, if I multiply that out, I get 0.5 of b, which is all fine. That's probably, if I was just drawing b, that would be good. But then I get 0.5 of 0.5a plus 0.5m, right? So now let's multiply that out. 0.5b plus 0.25a, right? Plus 0.25m. Do you see the problem? B and A are both part of my n layer. So if I now wanted to see what the total contribution of the n layer is, well, I could add these together. I could say that this was n and this was n, right? So the total contribution from the n layer is 0.75n plus my 0.25m, which is still there. Well, that's not 50% opacity, right? Not even close. So you can see what the problem is. If we layer multiple sprites at a certain opacity level on top of each other, what we end up is we darken the contribution. We increase the opacity every time they overlap, right? And we increase it by whatever that proportion actually is, right? The less this is, the less noticeable it would be, in theory, potentially, right? Because you're adding less each time, but still, right? It's always wrong. It's always the incorrect alpha, except at one exact point where it would happen to be okay, right? Which is if you only had one sprite. And as you get more and more and more sprites, it gets more and more and more wrong. Repeat this process one more time. This number will increase. This number will decrease. You'll get even more opaque. And off you go. So one solution to this problem, and the one that I was going to use, is just to say, okay, we could try to do some rendering tricks to maybe work this out. Maybe we use something in the destination alpha. Maybe we have a separate buffer. Maybe we do, who knows, blah, 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 right? We could do a depth pass first and have the depth pass then set to comparison so we could figure that out, whatever. There's lots of things we could do to solve this problem. The one that I'm choosing to do, and this is not necessarily for any reason other than I'd like to limit the degree to which we get into crazy shader ridiculousness, is to just render the scene in slices. Because if we render the scene in slices, we can choose to just do essentially this operation. P equals 1 minus alpha n plus alpha m. We can just say we composite everything for the n layer first and then just draw it in one pass. So rather than changing the alpha opacity on all of the sprites to fade out the layer, we actually draw the layer normally with whatever the sprite's actual alpha values are, which most of the time is 1, but if something's, maybe transparent, then it's less. We draw that first for the n layer, and we already have the m layer. We then just do our composite operation on top of them, and we get the right results because we're only applying the equation once, no matter how many sprites were in the n layer, because they've already been composited into essentially a single big sprite that can just be composited once. Okay? So that's the idea, if that makes sense. And, I'm not 100% certain, but we may be able to implement that in a way that might be somewhat tricky as well. I'm not sure. But we can see when we actually get to there, we may be able to do things where we don't actually have to render separately. But worst case, all we're talking about here when we do this is just having a few render buffers, right? So rather than having just one thing we render to on the screen, we would have a number of render buffers, and the number of render buffers is proportional to the number of these operations we plan to do. Now, from what we looked at originally, right, we don't have that many of these operations. We have a fog effect, which actually doesn't need this because it doesn't have this problem, right? For all the layers that are lower than the current layer. So as we go down, right? As we go down from, if this is the layer the hero is standing on, as we go down, these get fogged. And fog doesn't have a problem. Fog is not an opacity, right? Fog is a color effect. So we're not drawing things on top of each other multiple times. So fog, we don't have to deal with in this way. So we can actually composite all of the layers from the hero all the way down to the lowest level can be done into one buffer, right? So the only thing we need to do to get this effect is the single layer that's above the hero, right? That one has to be done this way. So essentially what we're talking about here is we have to do one of these that has that property to it, and then the rest of them will just work. So, worst case scenario, we're talking basically 2 render buffers. So that's fine because, 1920 by 1080, right? If we have 1920 by 1080 by 4 bytes per pixel, that is an extremely modest amount of size, right? It's about 8 megabytes. Oops. No. Right? And so saying that we need a second one of these, right, about 16 megs, is really not problematic in any way. And it's not problematic from two points of view, really. First, we are not going to be stressing the graphics card's memory subsystem in terms of allocation at all to say we need 2 8 meg buffers, right? Most graphics cards today have at least half a gigabyte of memory, oftentimes have a gigabyte, oftentimes have 2 gigabytes, right? And by the way, in that way that it's not particularly accurate, but hey, you can get some idea of what's going on. If you look at the Steam hardware survey, there's basically breakpoints right around that sort of level. You can see them here. So you can see right around half a gigabyte, you've got a reasonable amount of people who fall in there. About 10% of the people fall in about somewhere around a half a gig. Then you've got another really big breakpoint up here at a gigabyte. A lot of people falling into that category, almost a third of all cards. And then you've got a bunch of about probably the other third or so is somewhere above there, right? Is probably even more than a third, it looks like. Yeah, so even more than a third is up above in the 2 gig. And so when you talk about when you talk about the bottom number you can even have is 256 megabytes, then looking at 16 megabytes as a number is not threatening, right? So if you say I need to render buffers for a 1080p game, you're not. That's child's play on any PC, certainly. Now, maybe you talk about the Raspberry Pi or something, but who knows? Maybe we don't run 1080p on weak hardware, right? So that's totally fine. The other way that it's totally fine is the memory bandwidth necessary to do that extra blit is pretty minimal as well, right? If you're talking about an 8 megabyte copy, again, you can get a little bit of idea, and this is, again, only very ballpark, but you can do, list of NVIDIA hardware or something like this, and you can go pick, some graphics processing unit off of here. Let's pick something not necessarily top of the line or something. Let's just say a GeForce 600 series processor, like a, heck, we'll even do a mobile part, right? So if you take a look at what the graphics memory bandwidth here is, you can see right here, it's in gigabytes a second, right? And you can see that, even the most modest one is 14.4 gigabytes per second. So if you look at how many that's going to be for a particular frame, and that's really weak sauce because this is a mobile part, low-end mobile part, super lousy. So we're talking about at 60 frames a second, what is that, 240 megabytes we could do each frame of memory bandwidth. Again, totally random pulling that out there, but so if you're talking about just adding 8 megabytes more of bandwidth that we have to do that alpha composite pass, not a big deal, right? And hopefully you understand sort of what I'm talking about there. The idea is just that, well, originally we drew everything to the screen. So however much memory bandwidth that took the graphics card to do, pulling in the sprites, splitting them on top of each other, reading the Z buffer, writing the Z buffer, reading the color buffers, writing the color buffers, whatever it's doing, right? All of that stuff is the memory bandwidth necessary to run the game, and we do, every 60th of a second, we need that much memory bandwidth to make the game happen and not miss its frame rate. So when you say I need to add a second composite pass, what you're talking about is using up however big the screen's memory, however much memory it takes to store one screen's worth of data. If you're talking about a second slice, now you're talking about, well, I've got to do this alpha composite operation of that slice is adding, right? Because you still have to do all the sprite blitz, right? All of the sprite operations, you're still doing them. You're doing them to two separate buffers, right? Some of them go to one buffer, some go to the other. You're still doing all of that. So all of that memory bandwidth, you're still taking that hit. But now you also have to pay the cost of copying the on top buffer onto the lower buffer, and that is going to take the extra 8 megabytes of memory bandwidth, assuming that there's no compression or blah, 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 blah. But you get the idea, right? So somewhere in that ballpark. And so usually when you're doing stuff like this, is any of this stuff that you can really work out on paper? No, because it's all super specific to what's going on with the memory subsystems and, okay, what kind of shader operations are happening here, and is it compressed, and is the Z compressed, and can it early out, and blah, blah, blah. So there's so many different things in there that are involved. I don't want to give the impression that it's like, oh, that's how much more memory bandwidth it is. That's not true. But it always helps when you're in these situations. When you're working on code that has to do with performance, it always helps to just have in the back of your mind, what am I doing here? Like, is this a reasonable thing to even go, or is it a disaster? So if this number had come back and it was like, oh, it's 300 megabytes, right, or something like this, you would go, wait, hold on a second, right? First of all, I don't know if I have the memory bandwidth to do 300 megabytes extra of copying. Like, certain cards are now off the table, certainly. I mean, that's 300 megabytes would be more bandwidth at 60 frames a second than that mobile part we just looked at even had at all, right? So never mind rendering the game, just doing the alpha compositing would have killed it. But you'd also go, well, 300 megabytes is too much memory potentially too, because if all I have is 512 meg graphics card, let's say, well, if 300 megabytes of that graphics is just storing frame buffers, well, all of a sudden I'm like, where are the sprites gonna go, and where's where's some headroom for the operating system, and who knows? Like, I'm getting nervous, right? Already. So it just helps to know to sort of be aware of what these values are. I think Mike Abrash used to call these back of the envelope computations. It's a common industry term. But it's basically just like being aware that anytime you're making decisions like this, you should at least have an idea of what's involved. You shouldn't just be completely oblivious to like what actually has to happen in order to make that be the case. So that's why I always kind of sanity check myself there, and that's negligible. I think that's something that we won't have to care about at all, and we're fine. So yeah. So what we need to do now is we need to start pushing forwards on two fundamental pieces of this problem, I guess is what I would say. The first piece is we have to actually get our transform straightened out, because now we've got two different meanings for Z, and we need to have some idea of how that's going to work out, right? And the second thing that we need to do is, and like I said, we can also put, if we want to, we can put this back temporarily. If we want to work on them separately, I don't know if we do or don't, but you know, I think maybe we might want to. If we take a look at this here, you know, we could start with this and say, well, separate from the transform, let's just get the renderer handling the concept that we have these two different slices, and then let's alpha blend those two things on top of each other correctly, right? And I thought we had alpha being specified here, but now I don't see it. And so I'm wondering why the alpha isn't set on these to begin with. So maybe the first thing I'll do is just take a look at why that is the case. So I thought that was specified up in here, right? And I don't actually know why it's not at the moment. I'm not sure. It looks like it's because, oh, well, you know why. I guess what happened, I guess I see what happened actually now that I think about it. What's going on here is just that we had already partitioned it, and so we're not setting the entity alpha, right? We're just, let me just verify that that's true. So if I wanted to set the entity alpha, I think, do we still have the global alpha concept? Probably not. But if we wanted to set the entity alpha, what I could do is say, well, what should the entity alpha be? Because we're in here and we've got this like level index concept. So what I should be able to do here is say, well, this cliprect fx thing here's where I do my push cliprect. Well, I guess now it looks like there's no way for me to really get out what that alpha value should have been. Let me just do it this way. I want to just be able to, I guess, get this myself since we won't be able to look it up any other way. I'm going to call this test alpha. I'm just going to do, you know, however many of these there are, I want to get that out. So here we'll just say, well, the test alpha for our level index equals whatever the whatever this thing said the alpha value was, right? So you can see here, if we're above the fade top Z, we do a T color to 0, 0, 0 of this T value. So I think really all we want to do is say the test alpha is, I guess, 1 minus whatever that T color is. Right. So that way I've stored it. And then if I go through here, and we should be able to link live code it at this, so we should be able to go through here and actually make this work this way. So when I actually go ahead and do the rendering of this guy, when we do the pieces and the collision volume traversables, all that stuff, I should be able to say like, oh, well, what was the alpha supposed to be here? And I could put that in, right? I can sort of just say, well, you know, whatever the alpha was supposed to be, off we go. And so this would be, you know, v4 color equals piece color, color alpha times equals alpha. Right. And so now what we need to do is actually look up that alpha. So in here where we say like, oh, what's the relative layer, then we would have to say, well, the alpha value is going to be the test alpha of whatever the relative layer is, right? And since we have to base that off of our base level, we got to put that in there. All right. So let's see what happens here. So as I climb up the stairs, we should see this fade in, but that is actually not at all what I'm seeing, which is weird. Which is good I verified this, because I want to make sure this is correct first. Yeah, it looks like that just switches immediately. Why am I getting this result? Why, I ask? Why? So I have my level index, And I'm writing in whatever this value is. I would like to look at that value personally. And let's take a look inside Handmade Entity. I just want to see, when we come in here, I just want to see what this actually says. So here are my test alphas. 1, 1, 1, 1, 1, 0. All right. Let's be a little bit more forthcoming there. Let's see what happens in this case. Okay, so basically no one is above fade top start Z. Oh, no, there we go. So what's my T value? T value is 1. All right. Well, if you say so. I guess I'm not going to yell at you yet for being a liar. But eventually you fade in right there. So now what do you think your T value is? You think your T value is 1 now as well? What am I missing here? Camera relative ground Z, fade top start Z. So that is actually quite a bit higher. Is there another? There's only one ever that's above, right? All right, I'm a little perplexed. I don't mind telling you. What's fade? I want to see what the fade top NZ is as well. 2.25. So it's definitely outside, but yet at the same time, right, I'm looking at it. So I don't understand. Casey is confused. Quite confused, actually. So when I'm here, then I do expect it to be faded out completely. And when I see it, right, and I look, that's exactly what I get. My top end is 2.25. The relative positioning of this layer is 3.0. It's exactly right, right? That looks like exactly what I would expect. However, if I go up the stairs now, right, I don't expect to see that at all. That isn't what I would have expected to see, right? I guess, is it because the world has now shifted down? I guess I should probably look at what the actual Z is that we're talking about here. So if I take this, right, and I look at what the offset Z is from the, actually, I guess that's not so much what I want. I want the chunk. So that's chunk 1. Were we on chunk 0 before? Okay, so basically what happens is it's sliding us up before the fade actually has a chance to take effect. Can't say I didn't necessarily see that one coming, but so I guess I'm not 100% certain how we ended up in that place. But that does mean that, you know, the way that we're doing our fade-ins, our fade-in has to happen further up, I guess, is what I would say, in order for it to actually come in before it gets switched to as sort of the new normal, if you will. But I don't understand, because if you look at the typical floor heights here, if half a typical floor height is where it starts fading in, and 2/3 of it is where it fades out, is where it stops fading in, I don't know, that just seems really weird. Let's try something more like this. Okay, so nobody's over the fade top start Z at this point. Take a look at what we're looking at here. There we go. I'm going to step through this actually one by one. There we go. So let's see. We have -12, we have -9, -6, -3, the one we're actually on, which is 0, the one above us, which is at 3. And then, of course, we've got our fade top start Z is 3. So, yeah. I don't know. I'm a little perplexed. Maybe it's just a slow day. It happens sometimes. But it feels like, yeah, as long as we, you know, I don't really understand why starting it here wouldn't have worked. I mean, it feels like that should be a reasonable alpha region for doing the transition. All right, so there we've at least got it in the range. But it doesn't even seem to really do the range map. It just has its own... This feels really sloppy. I feel like there's something I'm missing. All right. We're going to have to drill down on this because I'm not happy about this. This is obviously something I'm doing stupid. In the meantime, I should probably, when we were doing our sort of, when we draw a rectangle, we outlined it, which is actually pretty good and it makes it easier to see stuff. But I do want to make sure I get the alpha more correct. So what I'd rather do is take the Primo Colors alpha here and make sure that that gets respected. That way at least everything fades out together. So, you know, it doesn't, we don't have the rectangle's line staying around, right? But you can see that they just, the things basically are popping out of that range. And we've got kind of a nasty, I think this is kind of busted. So I think what's happening is this computation is not quite correct. So I feel like if it might be this idea right here that's kind of busted. In fact, I'm not really sure why I did it this way at all, because it seems like the camera relative ground Z, this should have been subtracted, right? It feels like this should have been like this. But that's not what we wrote. So I'm going to go work this out on the blackboard and figure out if I'm just on crack or if we were just doing something stupid there, right? But yeah, either way, it doesn't work. So I'm not sure why we wrote that, and I'm not really sure why this isn't working more correctly. It's very tricky, don't get me wrong, but I just kind of want to know what's going on. So here is the situation as we have it. We have some number of stacks here, and somewhere in here is the actual simulation origin. Now, most of the time, it's going to actually probably coincide with one of these slices. So it's going to actually be like right on one of these slices. So then our question is, well, you know, oh, wait. That might be it right there. what's the actual camera part of this? Because this is the origin of the simulation region, but the camera is actually in a different place, right? The camera does this nonsense. So, right, this is the camera situation where we say like, okay, you know, world mode camera offset. So I think that's the problem, is the simulation region moves in steps. So if we actually want to know, you know, this is fine, but if we actually want to know where it is relative to the camera, we've got to subtract away the world mode camera offset z. Right? And we weren't doing that. So that we just kind of left ourselves some bad code there when we were working on that to begin with. I don't know why or how that was working in the first place, but there we go. So now we're fine again, right? Now everything's happy. So now we can kind of see like, all right, now we get our fade back. That's all nice, right? And when we get down here, we're good to go again. So that's all much more fancy and happy. All right, let's just double check. Start to fade. Start to fade. All looks good. All right. And maybe we can make this a little bit wider. Again, just, I don't know, we'll tweak those values later on, but no, that's not good. So let's see if this makes things a little more gradual. Still not great. Well, we'll have plenty of time to play with that anyway. All right. So yeah. So that's basically what we're looking at here, and like I said, what we want to do now is we want to kind of get these things to be in layers more properly. And we kind of already have a little bit of a problem, in my opinion, which is that our layer selection doesn't seem to be quite correct. Because if you look at what's going on here, these stairs should all be part of my layer, right? Because we're supposed to be flooring, pun intended, I think, what layer we're on. And so when we do recanonicalize coordinate here like this, I feel like that's a mistake, because that's not what we actually want. Essentially what we're doing at the moment is we're rounding. And so what I think we need to do is our recanonicalized coordinate, unfortunately, is just kind of wrong for z. Because if you remember, the way that we decided to do this, and maybe this was a mistake, but this is how we were doing it, is if you remember, we had sort of tiles in the world, right? And we stored things relative to the tile, the center of the tile. And we had switched because we were in the previous time we were doing it relative to the corner. That's how we were working things out, right? And we don't really have, there's really no rhyme or reason for why you would have to do it one way or the other. But now we sort of do have a little bit of a rhyme or a reason, right? Because once we extend this to 3D, which we now have, we now do have a reason to decide, right? If our goal is to make everything contained herein be part of this level, and then everything that's on this plane and up be part of this level, right? Then we want more of a truncate, right? We want a operation that's more truncation based than centroid based. Now, it doesn't really matter because we can just decide how we want to layer these things together. But what it does mean is if we want to continue with a centroid based scheme, where we put the floor needs to be placed down a bit, right? Or up a bit, depending on how we want that box to work out. So for example, what I'm currently conceptualizing, pretend these are the two floors we actually have. Here is this, well, no. So here are a bunch of people with z displacements. And the problem is right now we've got a rule which basically says, well, everything between here and here is on this floor, and everything between here and here is on this floor, right? And so what happens is these guys, they get kind of picked up. And if I drew this from the side, which I probably is what I should have done to begin with, if I drew it like this, right? Here's that stairwell. Here's those displacements. Okay? And if I'm looking at this and going, well, you know, I've got this problem where this is what's my definition of who falls into which brackets. Well, the problem now is these guys fall into the correct bracket, but these guys who I actually want to be down here are falling into this bracket. So what I need to do is push the floors downward. So the floors should actually be at negative something relative to their centroid, right? In order to make it so that everything that might be offset from them, all of the ground layers, are always up. And that's fine, right? We can just say that that's how that works. That's not a problem at all. We could just go into world mode or something, right? And we can take a look at when we do add standard room. You can see how we're adding things, you know. And when we come in here, we've got the like p offset z value, right? And so when we call chunk position from tile position, it's implicit in there that what it's doing is it's giving us that sort of floor level, right? And so you can see that that's happening here, and it just kind of does its mapping, right? But what we really want to do in that case is we want to say that the offset z value is actually going to be down a little from the size of a tile. So we want it to be like the tile depth in meters. We want it to be some, you know, whatever our region there would be. We would want it to be some ways down. Okay. So now, when we actually do that, in theory, well, I guess I don't actually know. I should double check to see that this is actually what we call all the time, but I think it is. Yeah. So now, when we actually do this, in theory, we should get, we should have all of the things moved down relative to, where we should have all entities moved downwards so that they aren't sorting up into the other thing. Now, unfortunately, I looked just then and saw that that's not actually what happened, right? Because we're still missing these two guys here. So it's a little odd to see them not there, right? No, that's what I would expect. So I'm going to have to go take a look at this now and just see what I actually see, why that is. Now, the other thing is this is getting kind of sloppy here. So these tile side in meters and tile depth in meters things, I think we had our kind of world concept here. We have the chunk dim in meters. So really, I feel like this should, you know, I feel like we should be getting this way. Right? And because I think that's what we decided for the chunk stuff. But anyway, so yeah, if that's the size of one of these things, and we're talking about 0, 0 being sort of a centroid point, then if we displace it downwards by, you know, almost half, then we're close to that floor level. That's what I would have expected. So I want to take a second to just go in and find out why that's not right before we exit. All right. So let's step into the world creation. I want to see what's going on with that chunk position from tile position bit. There we go. Scroll up here. So I just want to look and see what we've got. you can kind of see that we have a z displacement of negative 1.2. That's what we would expect, because that's going to be this divided, or times 0.4. So when we do our map into chunk space, I just want to look and see what the result ends up being. So yeah, that's like exactly what I would have expected it to be. So it's operating the way I would have thought. Let me take a look at the as standard room code. I just want to see what else it's doing here. So offset y plus 2. So this is the part that's actually displacing everything upwards here. So I'm not sure I really understand. I mean, that looks like it should do exactly what I'm asking it to do, and it feels like it should never be able to quite get high enough there. Now, maybe that's not true. Maybe what's happening is offset y is actually too large when we come in here. So if it's 3, I'm sorry, if it's between -2 and 2, then it's going to be 0 through 4. So what that means is we're going to add up to 2 units. That should not put us over the boundary, right? Our p offset z should always still be okay at that point, I should think. But I'm going to go ahead and take a look here. Oops. And let's go to the highest possible one. So 0, 1, 2. So there we go. And let's take a look at what our p offset z is now. Oops. So looking at our p offset, we've got negative 1.2 rather, which is what we wanted the floor height to be. We're now going to add to it the displacement for the highest level of the stairwell, and we can see that we get 0.8, right? Now, to me, that seems exactly right, because 0.8 is still going to sort onto the same layer. It's still going to snap when those coordinates are recanonicalized. So I think I did what I wanted to do here, in that all of these people are going to still be in that same chunk, right? But obviously, that's not true, because that's not what we're getting here. So I'm interested to know if we do step into here and just take a look at what some of the z-values are. What are the z-values that we're actually looking at here? So I'm getting a z-value of 0, and I'm getting that a lot. And I'm wondering, how am I getting a z-value of 0, right? And I'm guessing that probably what's happening there is the camera is getting set to the location of something specific, which is undoing the displacement that I did, right? So things are sorting into the right chunk area, but we're not actually getting that same sorting on the way out. Now, mind you, what we should be doing is just using the chunk in the first place for how we do the rendering, but that's sort of a separate issue. We'll get to that as we kind of collapse things down as we go further. So if I take a look here at the entity transform with the default upright transform bit, and then we do sort of the get ground point entity minus the camera p. So what we can see happening there is I'm not really, this is not really correct, right? We're not actually using absolute coordinates here, which is what we should actually be using. What we should actually be doing here is saying, well, where is the entity in absolute coordinates, which is get entity ground point, I guess. Well, actually, I don't even know. Entity ground point is relative to the sim region, right? And so what I need to do is I want to know specifically what the difference is in chunk z between these two things. I want to know the difference in chunk z between the entity that I'm rendering and the sim origin. So really, this is all noise at some level, and not really what we want to be doing. But that's okay, right? Like we just sort of popped back over here. So it's, we're getting our bearings. We're not expected to know everything right away. So yeah, what we wanted to do here is say, okay, really what's going on here is I want to know, for purposes of the relative layer alpha lookup, right? What I would actually want to know for the alpha lookup is I want to know, or rather, what I want to know to figure out which layer I'm in, is really just saying, well, where is this entity's actual location in the world, right? So who knows where that is exactly, but I want to basically go like world locate, world position. And I want to do the chunk z of that minus the whatever the simulation origin is, or whatever the fundamental point around which I'm looking. So I want the sim region's origin, chunk z. That is the actual location I care about, right? Now, unfortunately, I'm out of time, but that is what we will do tomorrow. And then we will take a look at what we want to do for the rest of this stuff. I think we don't care about this anymore, right? Because this is computing the distance from the camera in Z, which we don't care about, because it's only the layers themselves that will have that be relevant. So we have plenty of work to do, but now we know what we're actually doing. I'm going to put a to do in here. To do, Casey. It's the chunk Z difference that tells us what the relative layer is. I already sent this bug to Alan, so hopefully next version of Forcoder will have... there is a bug that got introduced regarding multi-line double slash comments. But so relative layer is, and we no longer care about the camera Z delta because things inside a layer aren't transformed proportionally or prospectively anymore. All right. So we'll go ahead and tackle that tomorrow, and I'll go to the Q&A now, which I'm going to have to teach this machine to not blank the screen. So while I wait for the Q&A, I will, let's see here. How do I tell this little fellow? System settings? Yeah, time and date, hardware detection, appearance, window management, desktop behavior, setup and shutdown, hardware, power management, maybe. On AC power, don't dim the screen, don't do that. No, no, no. Apply. Like, no. Okay, so maybe that'll work. I don't really know. We'll see. Okay. All right. Now we're good to go. InsoBot does do a great job of asking questions. It's true. No questions? What keyboard do I have? Well, thanks to Miblo and Fiery Drake, I have a Razer Black Widow Stealth Tournament Edition, actually, which was sent to me as a gift by those two fine gentlemen. And I am absolutely delighted to be typing on it because it's so much better than the DOS keyboard. It's not even funny. I have one of these at work. It's what I type on at work, and it's awesome. And they sent me one for typing on Handmade Hero, and it's been extremely it's been very, very pleasurable. Typing is like, I really enjoy the act of typing, which is probably why I'm a programmer in the first place, to be honest, because I feel like if you don't enjoy the act of typing, it's got to be pretty hard to want to work on a computer all day. But it just feels great to type on these things. They feel fantastic. I really like their switches. The Cherry MX switches were always just too hard, in my opinion. I like almost no activation force. Like, I want the key to just like bottom, like just whoosh, like putting your finger in a cloud. And these I think they're called Razer Orange switches, are lighter touch than Cherry MX Browns, which is what I was looking. And that lighter touch makes a big difference for me. Best of luck. Do you expect that the final game will contain enough sprites to warrant using a texture atlas to reduce the number of texture binds per frame? Well, I mean, it depends on the circumstances. Probably not. It'd be pretty unlikely. But in either case, that's really only an AMD hardware question, I think. Wait, is it even? No. I guess there really isn't. I don't think there's anybody who has texture change overhead anymore. Is there? I don't even think Intel does. So it'd be basically if you're trying to work on really old hardware, because nowadays there's no penalty for changing the texture handle, right? You don't. It's just like changing the constant store, right? So it's just like trivial. You could even put it in the vertex if you wanted to. So really, that's a very specific hardware question. It's like, on an NVIDIA card, absolutely not. Like any NVIDIA card it won't matter at all, because you can just use bindless on your textures and be done, right? And then you never have a texture bind, right? But on other hardware, that's not as true. So depending on the hardware that you target, you would then be able to answer that question. But it's certainly not something I would care about, well, till we end up going to ship the game, right? Because it doesn't matter, right? It's something we could go put in a texture atlas after the game's done, or after it's shipped even, and it's not going to affect the architecture. It just means we have to write a better asset manager than the one we wrote, because now it has to think about how it's going to page things in and out in a much more specific way. I don't understand why base Z value of each floor would be negative. It seems really contrived. It seems very logical to me to have 0 as the bottom. Maybe it has to do with rendering. I have not followed the latest shows. Well, it's a very, very straightforward decision you can make, and you can make it any way you want. So saying contrived, I guess I would object, because it's sort of makes it sound like there's a right answer, but there isn't. You have a cube, right? In Handmade Hero, we call these chunks, but it's basically a spatial partition where we... Clearly, I did not do a good enough job telling it not to blank my screen. Stop blanking my screen. Options. How do I tell it? Sorry, I gotta tell this thing to stop blanking my screen because I can't see the chat when it does that. So let's see. Screensaver. Screen locking. Screen locking is in desktop behavior. Okay, screen locking. Lock screen automatically. Don't do that. There you go. apply. Okay. Hopefully now we're good. So you have two choices, right? We are essentially a 3D world in Handmade Hero, right? You can move things around in 3D. So although we're 2D sprites and stuff, we don't have a 2D world representation. Our representation is 3D. So the question is, for this chunk, where would you like the sort of, canonical point inside a chunk to be? Would you like it to be at one of the corners, say for example here? Would you like it to be in the middle? Would you like it to be in the middle in X and Y, but at the bottom in Z, all right? You can pick any one of those that you want, but which one you pick determines what your base value is for a relative location. So, if you were to pick the corner or the center but bottom, right? Then your Z value for the floor would be, maybe 0. You probably still wouldn't get 0 for a floor value because then it's right on the edge, which seems like it's going to cause you some rounding headaches. So you would probably still want it to be at 0.1 or something just to, save yourself some trouble, but whatever you want to do. If, on the other hand, you pick the center of the cube as the canonical point, then the floor relative to that canonical point is going to be at negative something, which is however far down you want the floor to be, 0.5, point whatever, right? So you can choose however you want to do that, but there isn't a right answer. It's no more right to say that the floor is at 0.1 than it is to say that the floor is at 0.7 or something, right? It's completely arbitrary. It's just whatever your reference point happened to be. But I would argue that if one was going to be persnickety about it, actually it's floor at 0 that makes the least sense if you're not going to pick a corner for everything. So if you pick the center bottom, that's weird because now your coordinates are handled very non-homogeneously inside all of your computations, because now everything is about the center if you're in X and Y, but it's about the minimum if you're in Z. So you've drawn this weird distinction. So now all your routines have to be bifurcated. Every time you're dealing with Z, you do one thing, and X and Y, you do the other. Now, that's fine if you actually had to, right? Because, obviously in the renderer, we're already doing some things where we have to treat Z separately. But we're not treating Z separately just because we like treating Z separately. I would love to treat Z exactly the same. But we have to because we have certain effects that are based entirely on Z. Well, in the spatial partition, on the other hand, there's no difference between these three. Why would we introduce an artificial difference? So I would argue that, okay, if you decided, let's say you decided that you really want the floor at 0. That's just what you really have to have it. Okay, fine, your decision, but I would argue that at that point, X and Y should now be also based on the minimum corner of the cube, not the center. Right now we're center, right? And so I would want to move everything to min. So it's min X, min Y, min Z at that point. And hopefully you can see why I think that is true. All right, I am going to wrap it up. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with a source code. So you can play around with it and do your own experiments. For example, if you wanted Z to be at 0, you could very easily go do that. We have a forum site you can go if you want to ask questions. We have a Patreon page if you want to support the video series, a schedule bot you can use to see when the series is going to be live, and an episode guide you can go to catch up on past episodes. And I highly recommend using the schedule bot because a lot of times on the stream, in fact, I did it yesterday, or 2 days ago rather, I'll say we'll be back here tomorrow at blah when the schedule is not for us to be back here by. I tend to be absent-minded about it, so the schedule bot is almost always accurate. I am not. So always check the schedule bot if you want to know when we're going to be live. It's the surest thing to do. That's about it. I believe, if I'm not mistaken, but I just said don't trust me, that I'll be back here tomorrow at 8 p.m. Pacific Daylight Time. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.